Alright, welcome to another video about this time simplifying radicals, and we'll look at adding and subtracting. So I thought it'd be useful to put all of our perfect squares and perfect cubes up in the top right. As we go on, we should get used to just knowing these numbers in our heads. I'm just going to draw little arrows here to show that these go on and on. Don't think that they end there. They just keep going and going, but those are kind of the keys that we want. Key ones we want to know. So first of all, we want to square root 50. We're trying to simplify it. You have to think of a factor that's a perfect square, like 25, and then you can bring that 25 out and it becomes a 5. When you square root 25, you get 5. You can check on your calculator that root 50 is the same thing as 5 root 2. Turns out they are. It's a little bit more than 7, but that's not really what we're trying to do. If you're trying to simplify, you just want to leave it in that mixed radical form, and we're done. And there's just a little note that root a times b is the same as root a times root b, which is why this works. Alright, next up, let's say you had root 200x cubed. Break that up into 100 times 2. You square root the 100, you get a 10. And you can square root the x squared to get an x. Notice we can't really do much with that x. It has to stay inside the radical along with the 2. So I tried to color code it there so you can see which one came from which place, and you're done that question. Alright, next up, let's put a coefficient in front. So that's a 7 times the square root of 80x to the 6 y to the 9. So again, we're going to break up everything in the radical strategically. I'm going to choose 16 because it's a perfect square. And x to the 6 I'll leave, but I'm going to break up y to the 9 into 8 and 1 because I want it to be an even power when I take its square root. There we go. And anything you take out in front of the radical, you multiply by the 7 that was already there. And there's our final answer. And there's a little note about why the square root of x to the 6th is y to the 3. Alright, so fourth question. Now we're going to look at a cube root. Okay, so now we're going to do a cube root of 128x cubed. So first of all, we have to look to the other list there of perfect cubes. And we recognize that 64 is a factor of 128. 64 is also a perfect cube, so it's a good choice. Its cube root is 4, because 4 cubed is 64. So when we sort of evaluate it, oh, and there's no cube root of x cubed is just x. When we evaluate cube root of 64, we get a 4 out in front, and that's our final answer there. 4x times the cube root of 2. Right, here's one with a negative out front. We have an 80. Now notice we don't want to use 16 and 5 again, like we did previously. This time we're going to use 8 and 10 because it's a cube root, and 8 is a perfect cube. So we can take that 8 out, we can evaluate it, the cube root, it becomes a 2. We go across, notice you take all the y's out as well. Cube root of x to the 6th is y squared. And we do have to leave the 10 and the x squared in the cube root because we can't reduce those any further. Alright, now we're going to move on, switch gears a little bit into adding or subtracting radicals. What this basically means is that you're collecting like terms, but instead of terms we call them like radicals. So at first glance, all of these radicals will look very different, but if we simplify them, we can find that they actually have something in common. So if we break these down, now this one's a little tricky. I'm going to try on my calculator, see if 3 goes into it, because the other one seems to have a root 3 out there. And nicely enough, it does. 144 times 3 is 432. And that one's a little easier, 100 times 3. So what we can do is, once you reduce these, you can find that they all have a root 3. So then all you have to do is figure out each one's coefficient, and then you can combine them. So 5 plus 8 is 13, and 13 minus 25 is negative 12. So the final answer to this, negative 12 root 3. Now over to the side, I'm just going to use a different method to look at that root 432. Use a factor tree. So if you couldn't figure out that 144 went into it, this is another way that you could reduce that radical into simpler forms. Maybe you didn't have a calculator or something, so that would be another reason why you might want to do a factor tree. So we can rewrite it. That's called prime factorization, which means if you try to reduce it, will look something like this. A 3 comes out, 2 squared comes out, you're left with a 3. We get the same answer we had before, which was 12 root 3. Alright, so here's another one. This time we'll put some variables in there, and again, these look different, but what we're going to find is that they're all actually going to have a root 7x term. In this case, because 4 times 7 makes 28, when we bring things out of that radical and we apply the radical rules, you'll find that you get left with a 7x on the inside. In the second case there's 6x on the outside. And notice I got a 3 on the top because square root of 9 is 3. So we put this all together, you've got a 5x, a 6x, and a negative 1x. They all share the same radical and they have like terms in front of the radical. So combine it all, you get 10x times the square root of 7x. Not sure I deleted that by accident. That's our answer. So that's a mixed radical in simplest terms. Alright, thanks for watching.